So in this video I wanted to talk about logarithmic functions. And like the last video, I'm going to start out with an example, not actually give you the format, and I won't actually give you the format straight away. So let's actually use a similar example to last videos. Let's say we have our block and it's filled with atoms, okay? They're all of the same element, right? And let's say every year, okay, so there are 100 atoms at first, okay? And every year, one half of them decay. Okay, so one half of them are going to be gone. And we actually know, we want to find out how many years need to pass for us to have 25 atoms, okay? So how many years would need to pass in order for this block to end with 25 atoms, right? So we can actually derive the right formula or the right function to use from the function that we had last video. So a times b to the x equals y, or which is equal to f of x. I'm going to use y now just for this video, but y and f of x, in this case, we can just interchange them, mostly, in this case. Okay, so we have this function that we have from last video, right? But instead, we're trying to find out what x is equal to, right? And we know what y is, right? So in our past videos, we've done inverses of functions. So if you don't know what that is, you might want to go back and check out those. But in our inverses of function videos, we learned that in order to solve a sort of situation like this, we can actually just take the inverse. And what that would do is that would create a function for us where we would have, that would derive a function for us after we completed all of the inversing, which I'll show you in a second, where x is our output and y is our input, okay? So the first thing that we need to do is switch the y and the x around. So we would say a times b to the y equals x, okay? I'm just going to go with this. If you don't know what it is, if you don't know what I'm doing, then you might want to go back to the inverse videos. But anyways, let's divide both sides by a so that we can isolate y. And we have b to the y equals x. And then we can take log sub b, right? Log base b. And then log base b. So x divided by a. And then we get log base b of x divided by a equals y. Okay, so again, if that didn't make sense, you can go and check out the inverse videos, but yeah. And what we're going to get is that x is now going to equal, well, we switch these around, right? So now x is actually going to equal the end amount of atoms. Okay? So instead of equaling the number of years, it's going to equal the n number of atoms. And what is y going to equal? Well, y is going to equal our number of years now. And what is b? Well, that's what we were multiplying by. So multiply by, I'll just write multiply. And what is a? It's going to be our first number. First number of atoms. Okay. So now we can actually use this to find out how many years need to have passed, right? So we can say x divided by a is 25 divided by 100. Okay, and we're going to take log base 1/2, right? Equals y, which is the number of years, right? We haven't figured that out yet. And that will turn out to be 2. So 2 years need to pass. And that is our answer. Now you might be thinking, wait, why didn't we just use this exponential function and use algebra to figure it out? Well, we could have done that, but it would have taken a lot longer than if we had just known this function off the top of our heads and applied it. Also, when you get deeper into functions, you probably will want to know this because when you're taking derivatives and integrals, which we won't get into in this video, you actually will need to have the function handy. That pretty much wraps up logarithmic functions. Thank you.